Welcome to Tech Diet. Let's dive into our today's problem. Find the minimum possible sum of a beautiful array. It says you are given a positive integer n and a target. An array nums is beautiful if it meets the following condition. The length of array should be equal to the given n. The nums should consist of pair by distinct positive integers. There doesn't exist two distinct indices I and j such that within that array range, the sum of those two digit comes out the given target. We need to return the minimum possible sum of this beautiful array that could be achieved, and we have to modulate that within the limits. So this was a tweak question. Earlier it was something else. So let's try to resolve this updated question. So let's go through our first test case. So given n is equal to 2, target is equal to 3, that means our array should have uh, two elements, and none of those two elements should equals target. That should be minimum. So let's just try adding by number one. We can add one. We can't add two here because otherwise it would give us the digit 3, because the target is 3. So the difference is 2. I'll add 2 to my skip list, and then we'll add the corresponding next digit, which is 3. So now I have passed my quota. I have two elements. The sum here is 4. So that is the solution that we have built in my earlier video as well. So we maintain the skip list. We'll check if it's the number is already present in the skip list. We'll add it to the array if it's not already added to the skip list, and we'll keep on doing that. So now the bounds have been changed. It's like 10 raised to the power 9 and 10 raised to the power 9. So let's just try to hop over the next test case. So again we have this n is equal to 3, target is equal to 3. So now we can add three elements. Let's start with 1. So far we have just one element. Can we add 2? We can't add. Can we add 3? We can add. Can we add 4? We can add. 2 is in my again in the skip list. So what's happening here is, if I increase my target to 4, let's say, so can I add 2? I can add. Can I add 3? No. Can I add 4? Yes. So this will be my corresponding answer. So what happens here is, let's do it one more time. Till target is equal to 6. Do it for target 6. We'll have 1. Can I add? I can't add 5 there. Can I add 2? Yes, but I now can't add 4. Can I add 3? Yeah, I can add. I can't add the counter 3. Anyway, it will be unique. So now can I add 4? 5? No. Can I add 6? So let's say if it is 5 letters, can I add 7? Yeah. So that will be my minimum possible sum. So what's happening here is, we always add the corresponding first half of the digits. So we have target 6. The first half will remain same because that will be ending up. So 1 will be paired with the n minus 1, 2 will be paired with n minus 2, the target minus 2. Similarly, the mid will be compared by the target by 2. So the first few elements will be always included, that will be like target by 2, and then after that, how many remaining element do I have that are yet to be completed? So here I have added 3 elements. I'm yet to add 2 more elements, which will be again starting from 6. So there's no way of any element that are beyond target will be equal to the target sum, because that will always be greater than the target. So that's what our new approach will be. So we'll find out the first half sum, then we'll find out the rest of the half sum, and we'll figure this out. So let's try to create a function which say void. Okay, it will give me the sum of given n elements. So let's add n here. So this will simply returns me n. By mathematics we know it is n into n minus n plus 1 by 2. So that will be our sum. Now we have to find first sum for target by 2. So let's calculate the sum of half target, which will be target by 2. Now let's call this sum of elements function, which will be our sum in the first halves. Um, okay, so now I have my sum till 1 to 3. Now I need to find what will be my last digit. Where will I end up? So this will be something like we'll have some till 1, 2, 3, and then till target by 2, and then I'll start again with target and target plus 1 till I need to do it n times, but I already added target by 2 terms, so minus 1. So this is the number of element that has been so far added here, and this is the so far that I want to achieve. So this will be my end target. This will be my total number of elements till I want to count. So let's add till nth target, which will be this particular value. So now let's calculate the sum of these first elements, first till target elements. Okay, so now I have a sum of 1, 2, 3 till my target, or let's say till 7. I have a sum from 1 to 3. I need to find the sum for this 1, 2, 3, 6, 7. So that means I need to exclude 4 and 5. So I know if I do this sum of the elements till target minus 1, I will get the sum of these elements. And from this whole sum, if I just exclude from 1 to 2, so from this one, if I just subtract it out, this 1 to 5, I'll just leave with 6 and 7, and then I can add it to my half sum. So that will be my answer. So let's compute this sum of the first sum of the first target minus 1 elements. So that will be like sum of target minus 1 elements will be the given sum, and the given target minus 1. So now I need to return. So my actual sum will be what is my half sum plus what is my till nth target sum minus what is my sum till n minus 1, the target minus 1, and then I can modulate it back as per our constraint. Then I can calculate the integer corresponding to this computation. So now let's try to run it. So it says it's accepted. Let's try with the custom test case we have. Let's say n is 13, this is some 40. Okay, it is failing, we are receiving negatives. So okay, so here the target half will be 20, and we have just 13 elements. So that means if my target half target is less than the number of elements I need, or if it's greater than the number of elements I need, then I just need to calculate the sum of first 10 digits. So that will be something like whatever your n is, multiply it with n plus 1 divided by 2, then we can modulate it back, then we can convert this back to int. Let's try to run it. Okay, this is accepted now. Let's try to hit submit. Yep, this looks good. Beats 100%. Thank you.